Hi, I'm Jenny Hess, teacher of fourth grade, and I want to talk about the strategies that we're using in our fourth grade classroom to meet the Common Core State Standard. I can multiply a whole number of up to 4 digits by a 1-digit whole number using strategies based on place value and the properties of operation, and illustrate and explain the calculation by using equations, rectangular arrays, and/or area models. The Common Core State Standards are adopted by the state of Oregon, and as teachers, we are contractually obligated and responsible to make sure that your children can meet those standards. The strategies that we use come from the curriculum that are provided to us and purchased by the district as a resource, and we teach your children those strategies. Those strategies probably to most of you will be unfamiliar, and depending on your experience with math might even seem unnecessary. But again, these are our responsibility, and the longer that I have done this, the more I have seen the really good things and outcomes that can come from learning different ways of doing multiplication and also division. The first one I want to talk about is where we start with multiplication, and that's the area model. We take a 2-digit number like 59 and multiply it by 3. And what we do is we take the larger of the numbers that are being multiplied and we break it up into multiplication equations that are much easier to calculate. And we use a rectangle to model how this multiplication works. I'm going to put a 3 here, and I'm going to break this number up into its expanded form, 50 and 9. Your children have been working with arrays for multiplication in a lot smaller scale since the beginning of the year. So this should not look unfamiliar to them. We are trying to find the total number of units in each square or rectangle, and then we're going to add them together to see what they are all together. I'm going to write the equation in here, 50 times 3, and then I'm going to multiply 9 times 3. This is a lot easier to multiply than 59 times 3. I put the 0 down here, I multiply 5 times 3, and that's 150. 5 times 3 is a much easier equation for children to multiply. 9 times 3 is 27. Before I add these together, I teach kids to write them down underneath as sort of an explanation of how they're getting their answer. 59 times 3 is equal to 50 times 3 plus 9 times 3. This is what's called the distributive property in mathematics, and it's going to be really important to them as they advance through 5th grade and middle school and beyond. 150 plus 27, and then we add those together, which of course is 177. So that is the answer. We can use this strategy with more than just 2 digits. Here is an example of what happens when you add hundreds to the first factor that you're multiplying. I can also keep extending this and still apply the same strategy and just add a different box for each place value, making sure that this isn't just 6, 5, and 9,
but this represents the value of the first digit, 600, the value of the next digit in the tens place, 50, and then 9. I would remind students that this represents an array with many different units in it, that even though this is out of proportion, the 3 really means that there are 3 rows, and these would be 600 columns, 50 columns, and 9 columns. Since I cannot draw out all the individual units, we have to just know that it's 600 times 3, and in this rectangle, I would get 1,800 units. Adding them all together, making sure I'm lining up my place value, I get 1,977. And that is the area model strategy for, I could do up to 4 digits by 1 digit multiplication.